Hello everyone. Welcome to BEX Basic Electronics lecture number 22. And today we are going to start with the regulator ICs 78XX series and 79XX series. So please write it down. First we'll start with 78XX series regulator IC. So please write along with me. Okay, regulator IC 78XX series. Alright, so these ICs are, let us write it down, first point in it. These are 3-terminal fixed positive voltage regulator ICs. 3-terminal fixed positive voltage regulator ICs. Okay. Here, write down. Here, XX indicate the DC output voltage. Here, XX indicate the DC output voltage. And these ICs provide output voltages of 5, 6, 8, 12, 15, 18 and 24 volts. Please write them down. So 5 volt, they provide DC output voltages of 5 volt, 6 volt, 8 volt, 12 volt, 15 volt, 18 and 24 volt. So for example, let's take an example. Example 7812 represents a 12 volt regulator. That means the output voltage is 12 volt. Okay, a 12 volt regulator IC, a constant voltage. So these are the configurations: 7805, 7806, 7808, 7812, 7815, 7818, 7824. So we have to write the corresponding output voltages. So the output voltages are, here it provides output voltage of 5 volt, 6 volt, 8, 12, 15, 18 and 24. Understood? So as the name last two digits XX represents the output voltages, DC output voltages. Is this understood, everyone? Yes? Okay. You have written. Now also, to add to these points, they are available both in metal and plastic packages. Okay, they are available both in metal and plastic packages. All right. Can we proceed further? Everyone? So metal package is, I'll just describe you all. Okay, let me read the comment. Okay, just a minute to note down. Okay, fine. Yeah, note it down, please. So till then, I'll draw the packages. So there are two packages, metal can and plastic packages. So let me draw one of them. So this is, I'm drawing plastic package, metal package. Okay. This is, there will be two casings over here. All right. This is metal can package. You have to draw this metal package, which is T03 type. Okay. Here let me mark the input and output. This is output pin. This is input, and this is my case actually, which is ground. So there are three terminals, 1, 2 and 3. So this is 1, 2 and 3 is my ground. Okay. So here pin number 1 is input, pin number 2 is output, and case is my ground. Okay. Case is ground. This is metal package. Please draw it along with me. Have you completed? This is the bottom view. Bottom view of metal package. Now I'll draw the plastic package, which is more often used. Have you completed this? Can I scroll down? Or you are still writing? Okay. Yeah, I will draw it over here. So this is my plastic package. Okay. Here it is. This is a heat sink provided. This is 78XX, or I can write 7805 or something. These are my leads. Please draw it along with me. This is 1, 2 and 3. So this is 1, 2 and 3. So here pin number 1 again is my input. Pin number 2 is output, and pin number 3, oh, pin number 2 is ground over here, sorry. Pin number 3 is output. So this package is called as plastic package. Alright, and its number is T0220 type, if you want to check its data sheet. So this is my plastic package. I hope you have drawn along with me, or you require some time to complete. Have you completed? Yes, no? Completed this? Yeah, students? Yeah, can I move on to the next page? So we are writing about 78XX IC regulator. So it provides a fixed output of 5 volt, 6 volt, 8 volt, and we have drawn the two packages, metal package and plastic package. In the exam you may draw any one. Okay, completed this? So this is my metal package and this is my plastic package, and they are available in these output for fixed voltages. Alright, now can we start with the connection diagram, internal diagram, connection diagram? Okay, let's move on to point number 5. So kindly draw the connection diagram. So first of all, let me just write it down. This is, let's draw the connection diagram. So you draw this as a rectangular box, the symbol form, and let's consider it as 7805 IC. Example. So we'll example use 7805 IC, regulator IC, 3 terminal. So which are the 3 terminals? Here, this is terminal number 1, which is input, terminal number 2, which is ground, and terminal number 3, which is output. So let me add over here, this is input, output, and ground. So how are the normally the connection diagram is? Between the input and ground, this is my ground actually. So let me add it over here like this. Yep. So between the input and the ground, we connect a capacitor, input capacitor, a ceramic input capacitor called as CI. Okay. And this is, what is this input? Input is unregulated DC input. So please mark it over here. I hope you all are writing along with me. Everyone, you all are with me? So please add over here. This is unregulated input. This is unregulated input voltage. And output over here, this is, here between output and ground we connect another capacitor, which we call it as C0. So here output is regulated output. Regulated output, V out. Okay, this is unregulated input V in. So this is V in. Yeah, this is unregulated input. This is regulated output. This is my input capacitor. This is output capacitor. These should be connected. So please draw them along with me. Are you all drawing this or writing this, or just I should go ahead with this? Hello? In your books? Can you just let me know so that I can increase or decrease my pace? You all are writing along now? Okay, okay. So this is the connection diagram for 7-8. Let's say for example 05 IC. So can we write the description over here? This is connection diagram for 7805 IC. Okay, let's write the description over here. So write down the unregulated input V in is applied to pin number 1. Okay, then here you can say pin number 2 is the common ground. Why I said common? Because it is common between input and output. Then and pin number 3 is the output terminal. So pin number 3 is the output terminal where we measure the regulated output, which provides a fixed output. Uh, Please keep your volume. Arif, please mute the volumes, everyone. Um, Recording going on, so please be careful. Anyways, let's continue. So the regulated input is applied to the pin number 1. Pin number 2 is the common ground. Pin number 3 is the output terminal. Where do you usually get the this thing output, regulated output? Then we write capacitor C1 CI. Capacitor CI is connected between input terminal and ground. Capacitor CI is connected between input terminal and the ground. So CI, capacitor CI is connected to prevent CI is connected. So write down capacitor CI is connected to prevent oscillations in the IC capacitor CI is connected to prevent the oscillations in the IC due to yeah, just let me change the wire of my writing pad. Okay, so capacitor CI is connected to prevent the oscillations in the IC due to lead inductance. Due to lead inductance. Now, what is this? I will inform you. So this happens due to lead inductance. This happens. So if you have your regulator IC like this, 7805, and you have pin number 1, and your circuit is over here. Very long wire is connected, right? Here like this. See, a long wire is connected and then connected to this. So this is a wire, a long wire, and this is the actual circuit which you have connecting in the breadboard. Let's say that you are connecting a capacitor over here. Okay, CI. So you connect it to a long wire and then you connect it to the input. So due to that, because of this long wire, there will be lead inductance present in the circuit, which might lead to oscillations. So you connect your, let's say this is not CI, this is something else, input. And because of this, we connect a capacitor. So moment we connect the capacitor, it will prevent oscillations because of this long leads. Are you understanding? Lead inductance, have you understood this? What do you mean by lead inductance? Long wire. Okay, so here means if regulator IC is at a distance from power supply. Okay, long distribution wires. So you have a long wire, then it will lead to lead inductance, and to prevent that, we connect CI. Are you understanding? Yeah. Now we go to the next one, capacitor CO. So write down capacitor CO improves is used to improve the transient response capacitor CO is used to improve the transient response. I'll explain what is transient response, just write it down right now. Transient response of the regulator. Okay. So what do you mean by transient response? Now we will write it down. That is the response of the regulator to the sudden changes in load. Okay, so it improves the transient response of the regulator IC. Completed up till now? Hello? So this capacitor also helps in also helps in reducing noise present noise present at the output. Okay, completed. Can I go to the next point, everyone? Okay, write down to point number 5. Let me check. Yeah, Manthan Parmar, you can ask the question. You have a doubt? Hello Manthan, you have a doubt?
नो सर, गलती से हो गया।
अच्छा अच्छा, लिख रहे हो ना?
हाँ हाँ।
Okay. So what we are doing is we are writing the description for this 7805. So ये सारे points लिखने हैं आपको, point number 1 to 5 related to this diagram. Okay. Now write down one last point. The input voltage. Now this is a necessity condition. This is a necessity. Okay. This is a necessary condition. The input voltage V in must be at least 2 to 3 volt more than the regulated output required output voltage required for proper operation. Now what is the meaning of this? I'll explain, don't worry. Meaning, if I have a regulator, let's say I have 7805 regulator, okay, I've connected over here, this is my input, okay, I've connected all my capacitors, assuming everything is there. This is my output. So let's say I know what is my output voltage. This should be plus minus 5 voltage, and this is fixed. Okay, ये fixed रहेगा. But to successfully operate this device, how much should be my input? 2 to 3 volts greater. So मेरा input जो है V in should be greater than at least 7 to 8 volts. Okay, तो safer range is 8 volts के ऊपर ही होना चाहिए. Okay, so if input is greater than 8 volts, then only this regulator IC will work. 2 to, or we can say 7 to 8 volts. Okay, now if it is a case of 7 8 1 2 regulator, तो बताइए अब इनपुट कितना होना चाहिए? What is the output of this?
12 वोल्ट आउटपुट।
Yes, plus 12 volt output. यहाँ पे plus 12 volt DC, तो इनपुट कितना होना चाहिए मिनिमम? Greater than at least
15।
हाँ 15 volts. So that's the meaning of it. Okay, that's the only meaning of it. The input voltage, ये बहुत important statement है, must be 2 to 3 volts more than the regulated output voltage required for proper operation. Okay, so please write down this point. समझ में आया ये बात? Okay, yes, and this thing is called as, इसको बोलते हैं, technical term called as dropout voltage. So what is dropout voltage? It is the difference between input and output terminals. It is the difference between V in and V out. Voltages. Okay. So dropout voltage can be written as V in minus V out. So for example, for 7812 IC, what is my dropout voltage? Around 2 to 3 volt, right? So V in कितना है यहाँ पे अपना 15 and V out is 12, so around 3 volts is my dropout voltage. Okay, yes or no?
Yes.
So what is the minimum voltage you apply at the input? तो आपका मिनिमम इनपुट डीसी वोल्टेज कितना होना चाहिए? मिनिमम इनपुट वोल्टेज that can be applied for proper operation, okay, of regulator is कितना होना चाहिए? V in minimum, V out plus dropout voltage is one and the same thing what I am explaining above. So ये पूरा reference के लिए था आपके. You need not write this in exam. This is for only reading लिखो. So even if you don't write it, it's fine. For reading only. I mean, read करके जाओगे तो अच्छा है. But it means the same thing only. Okay, V minimum is V out plus 3 volt. That is, input voltage should be 3 volts or 2 volts greater than output voltage. इसका meaning है dropout voltage. Understood this? This is available in the data sheet of the regulator IC. Is this clear? Yes or no? Hello? Okay. Now let us write down some characteristics. I don't know whether how much this will be asked in exam, but this I'll give you in this thing, the image, characteristics of positive 3 terminal fixed voltage regulator. This you can obtain from the data sheet also, let's say 78XX series. Okay, so number one characteristics is V out. इसको बोलते हैं regulated output voltage. Next characteristics is mod of V in, which should be greater than or equal to this plus 2 volt, at least 2 volts. Okay, this is minimum. Third characteristics is IO max, I out max or IO max. This I'll give you in writing, don't worry. So this is output load current. This is called as output load current. I'm just writing the names, that's it. Then it should have a thermal shutdown. Now can you explain what is a thermal shutdown? The IC has a regulator IC has a built-in temperature sensor which turns off the IC when it becomes too hot. समझ में आ रहा है? So it will shut down the IC automatically because उसके अंदर एक inbuilt temperature sensor है. Let's say as soon as one temperature is reached, let's say 50 degree reach हो गया. Okay, so it will shut off the IC. तो IC काम करना बंद कर देगी. It is called as automatic thermal shutdown. ये feature है, characteristics है. So the output current will drop and remain there until the IC is cooled significantly. The next is line or input regulation. This is one of the characteristics. So I'm not dictating this lines, I'll give it to you directly. Then there is load regulation. This typically for 7805 the value is 3 millivolt. Okay, then load regulation typically for 7805 the value is 15 millivolt. You know what is load and line regulation, right? Then finally ripple rejection. I mean these are the points which I'll give it to you. Ripple rejection, but we are not writing it right now because we don't not sure whether it is part of your curriculum or no. So but I'm not taking any risk. I made you write all the characteristics. Okay, so output regulated output voltage, minimum input voltage required, output load current, thermal shutdown feature, line regulation, load regulation, and ripple rejection. Yeah, someone has written something. अच्छा, सेकंड कैरेक्टरिस्टिक्स, सी वही बोला ना मैंने इधर, ड्रॉप आउट वोल्टेज, लेट्स से फॉर एग्जांपल 3 वोल्ट है यहाँ पे, इट कैन बी मिनिमम 2 वोल्ट ऑल्सो, सो इट कैन बी 14 माइनस प्लस 2 वोल्ट। सो यही लिखा है ना, वी आउट प्लस ड्रॉप आउट वोल्टेज। सो यही लिखा है यहाँ पे, देखो वी आउट प्लस ड्रॉप आउट वोल्टेज इज 2 वोल्ट फॉर ऑल दी ICs मोस्टली। Okay, then we have output load current. Of course, output load current may vary from 0 to rated maximum output current. So the ICs are usually provided with heat sink, otherwise they will not be able to provide a rated maximum output current. Matlab, it provides a constant DC voltage with some current also. Let's say it provides 5 volt with 1 ampere current capacity. So this is my output rated current, load current. Okay, so beyond that it will not support, beyond 1 ampere it will not support. So that is the 7805 IC, for example. ये output है उसका. So along with the voltage you have current also. Then thermal shutdown we already have understood. Line and load regulation, you know the variations, again line and load, the output should remain constant, and the ripple rejection. ठीक है? Okay, any doubt over here? Hello, do you have a doubt, anyone? No? Alright, so now we'll go for, can we go for 79XX series? Everyone? Any doubt in 78XX series? So let me revise what we have done. So generalize, we have written the what is a 78XX series. It's a 3-terminal fixed positive voltage regulator. XX indicate the DC output voltage. They provide output voltages of 5 volt, 6, 8, 12 plus, all plus, and we have drawn the metal and plastic packages. They are available both in metal and plastic packages. Okay, then we have drawn the connection diagram for the IC. So we have described why we require CI, CO, okay, and what is should be the input voltage. So all this up till here you have to explain in the exam. If they ask you, write a short note on 7805 or 78XX series, you have to write these 2 pages. Are you understanding? These 2 pages. Beyond that, I have just explained for the reading only. And I don't know whether characteristics will be asked, but I have made you write that. Okay? The characteristics ke description I'll give it to you later. Is that okay? Now, can we start with 7? Let us start with 7 9. Oh, 7 9. Whenever there is a 7 9 XX series regulator. Okay? So, write down the first point. Are you all ready? Everyone? Okay. So, write down, these are 3-terminal negative fixed voltage regulator ICs. So these are, वो 7 8 वाला was positive, this is negative, only that is the difference. Okay, these are 3-terminal negative fixed voltage regulator ICs. Point number 2, they provide, they are available in, they provide नहीं, they are available to provide output voltages of Actually, 9 output voltages they provide. 9 output voltages of options. 9 output voltages options. So, for example, we have -2 also they provide. -2, -5, -5.2. ये दोनों extra है, which were not there in positive voltage regulators. Then we have -6, -8, -12, -15, 18, and -24 volts. So they provide fixed negative voltages. Okay, you have written it. So for example, 7915 IC provides fixed -12 volts as output DC voltages. So you will say where we require -5 volts, right? So some circuits require positive and negative power supply both. So there you require this negative voltage supply also. Okay, like for example, I don't know whether you have heard of op amps. Some IC circuits require negative voltage and positive voltage to operate. So op amp is such an IC which require positive and negative voltage. So that's where we use a regulator IC, negative voltage regulator IC. Okay, so yeah, this is an example which we have given, and again they are available in, लिखो यहाँ पे, they are also available both in metal and plastic packages. So फटाफट बनाते हैं हम लोग वापस से metal and plastic packages. It will be a revision for you all. So वो जो metal package है, that is used for higher current rating. You can use it for a higher current rating. Its pin is different slightly over here, so please be careful. Can we start? Yeah, draw these packages. So first is my metal package. So this is this is my metal package. Here the pinout is different, so that's why we are drawing it. I'm not writing the number here. So here the pinout is pin number 1, 2. So here 1 is ground, 2 is output, and your case, the back case is input. Okay, so write the pinout over here. Pin number 1 is ground, pin number 2 is output, and pin number 3 is case, which is input. You have to take care of it. Then we'll draw the plastic package. So how does the plastic package looks like? Okay, like this. This is the plastic package 78XX series. Here we have the heat sink we can attach to it. Then you have these leads. Okay, so this is 1, 2, and 3, and this is my plastic package. Okay, so pin number 1 is ground, remember it. Pin number 2 is input, and pin number 3 is output. Okay, so you can describe, have you completed this? Now next we draw the connection diagram. So a connection diagram is similar, but only thing is, let's draw example of 7905. So this will provide output of minus 5 volt. Okay, at the output. So only thing is numbers are different, rest everything is same. We have Ci and Co, the function of it are same, so I'm not writing it again. This is ground, that is pin number 1. Pin number 2 is input, pin number 3 is output. So this is input, this is ground, and this is output. Okay, so here again we have a capacitor Ci, and here we have capacitor Co. But listen carefully how we are drawing it. Here I am writing, see how I am writing positive and negative. This is positive, this is negative. So this is unregulated input. Okay, unregulated input V in. Here also see how we are drawing this. This is positive, this is negative, and this is regulated output V out. Alright, rest the functions are same, only few lines will write. Completed this connection diagram. This is the connection diagram. Connection diagram for IC 7905. Okay, can we write the first point over here? Here we can write, in this regulator, that is 7905 IC, pin number 1 is the common ground terminal. Okay, pin number 1 is the common ground terminal. Then pin number 2 is the input terminal. So you apply your unregulated input voltage at pin number 2, and see the polarity over here. The polarity is reverse. You have to follow that. Whereas the polarity in case of earlier diagram I have not shown it, but it's positive negative. Let's like this. See, positive negative. So see the polarity change. We apply negative input to get a positive, to get a negative output. So here the polarity is positive negative. Are you following? Positive and negative like this. Okay. So pin number 2 is the input terminal. And what about pin number 3? Pin number 3 is the output terminal. Okay, I'll write the description for capacitor Ci and Co in short, because you have written it before. So D point is, write down capacitors Ci and Co are used to prevent oscillations and to improve the transient response. Transient response of the regulator. Okay, completed? I suppose you all were writing along with me, so you must have completed up till now. Let me know when you complete it. Okay, okay, take your time to complete it. So where do we use this regulator ICs? They are used in DC power supply. Okay, so if you build a AC to DC power supply, you plug into your mains, and at the output you should obtain a DC voltage, a fixed DC voltage. Then in there, at the last stage, you use a regulator IC. So we have learned Zener as a voltage regulator. That can help for to certain extent, but Zener as a voltage regulator won't provide you that much amount of output load current. Whereas a regulator IC can provide you maximum 1 ampere load current at in 78 and 79 series. So have you understood what is 78XX and 79XX series? Yes or no? So tell me, I'll give you an example. What is 7918 output voltage? Can you tell me? What is 78 for 78 what voltages we have in the range of, yeah, what is 7806 meaning? Tell me first case, what output it will provide? V out will be equal to, and here V out will be equal to, tell me.
minus 18
Yeah, minus
और
18
plus 6
प्लस 6, तो इसके लिए इनपुट कितना होना चाहिए, वी इन मिनिमम कितना होना चाहिए, और इसके लिए इनपुट कितना होना चाहिए, इसके लिए मिनिमम इनपुट शुड बी वी आउट प्लस 2 वोल्ट, करेक्ट, दैट शुड बी
yes
8 वोल्ट, एंड यहाँ पे वी आउट, अभी प्लस 2 कैसे लिखोगे यहाँ पे, या यू कैन राइट
plus
प्लस
minus 2
प्लस 2 ना, सो इट विल बी एटलीस्ट input should be, हाँ, we can write minus 2, of course, they are in negative, so it will be how much, minus 20 or minus 16,
minus 20 आएगा
are you sure, or minus 16 will come,
minus 18 minus 2 become minus 20
नहीं नहीं, its input voltage should be greater than the output voltage by 9, so greater मतलब इधर 16 आना चाहिए ना, minus 16, if you check, if you go by the magnitude only, then it should be minus 20, if you go by the magnitude only, okay, so this is V out, just consider the magnitude, and then at the end you put the sign, so this should be like this, right, ऐसे किया तो चलेगा ना, minus 18 plus 2, now okay, yeah, fine, so we have completed the topics of uh, regulator ICs. Now I don't know whether you have numerical on this. Last time I told you all to find out. Now, have you found out? Do you have numerical on regulator? Yes or no? Who have asked this topic? You have asked to your sir. Hello. NATO one small topic with small numerical. I can do it. No problem. So shall I do one numerical on this? Tell me fast. Then I'll leave you then. After drawing the numerical. Okay? Can I start? बताइए न्यूमेरिकल करना है या नहीं.
So let us start with the first numerical.
Sorry, I didn't hear you. What are you saying?
So let's start with the first numerical because as you told, asked the sir, but I sir was not present at that.
Okay, but
That's
design
why
of,
we
ठीक है ठीक है
not, yeah.
ठीक है, डिजाइन ऑफ प्लस माइनस 15 वोल्ट तो नहीं है ना पक्का? प्लस माइनस 5 एंड प्लस माइनस 15 वोल्ट नहीं है ना?
No, sir.
वो नहीं है ना?
नहीं है.
Okay, okay, fine. But okay, surprisingly, it's not there, but it was very easy and very important also. So write down one concept on the numerical. It will take around 15-20 minutes. We'll complete this also. So लिखो ये topic. I am showing you only 7-8 का example. It can be asked for 7-9 also. So fixed regulator. अगर हमें फिक्स रेगुलेटर को एडजस्टेबल बनाना है, फिक्स रेगुलेटर एस्ट एडजस्टेबल voltage regulator, तो कैसे बनाऊंगा? I'll see that procedure now. Because 78xx and 79xx से हमें फिक्स वोल्टेज मिलेगा. If I want it adjustable, मुझे एडजस्ट करना है वोल्टेज आउटपुट, तो then how will I connect it? So can it be used as a adjustable voltage regulator? The answer is yes. So let's take an example of again 7805 IC. So please draw it along with me quickly. 7805 IC बनाया हमने. Okay, this is 1, this is 2, and this is 3. So what do we do is we connect two external resistors. ऐसे देखो, one over here and one over here. ठीक है? Yes. And we connect pin number 2 over here. Normally not going to the ground, but over here. Fine. Obviously we will have the capacitor connected. Capacitor to रह गई. So I will be drawing capacitor in over here. Capacitor prevention के लिए तो रहता ही है. This is CI, this is CO. Just connect them, that's it. And output में हमारा क्या है? VO, V out. Yeah, plus minus V out. Let us call this resistor as R1 and R2. R2 is a variable resistor. So variable resistor को कैसे बताऊंगा? पोटेंशियोमीटर ऐसे. मतलब ये R2 can be varied, R1 cannot be varied. समझ में आया? So this is ground, this is input, and this is out. And this is your input V in, unregulated. ठीक है, तो ये मेरा हो गया कनेक्शन डायग्राम. And this current which is flowing out of this terminal is called as I adjustable. This is called as VR. This can be called as V pot, voltage across potentiometer. So voltage across R1 we call it as VR, and voltage across pot is called as V pot. Let's say this current is IR1. Okay. So this is called as adjustable voltage regulator using IC 7805. ओके, बनाया डायग्राम, सर्किट डायग्राम. सो यहाँ पे पॉइंट नंबर क्या है पता है? द आउटपुट वोल्टेज, हमारा आउटपुट वोल्टेज वी आउट, क्या फिर राइट इट केयरफुली. माय आउटपुट फिक्स वोल्टेज वी आउट वोल्टेज कैन बी वेरिड by changing the potentiometer. Pot is called as potentiometer. Potentiometer R2 value. You don't know how the potentiometer looks like? ऐसे रहता है ना पोटेंशियोमीटर, और बीच में एक ऐसे रहता है which you can move. Do you know this? Potentiometer has 3 terminals. 1, 2, 3. This is a pot. So middle is my variable terminal, last two are fixed terminals. So this value can be rotated by rotating this knob. Yes or no? So output voltage can be varied by changing the potentiometer value. Here the ground terminal is floating, it's not actually connected to the ground. तो मेरा आउटपुट वोल्टेज क्या आया बताइए? आउटपुट वोल्टेजेस ये दो टुकड़े ना VR प्लस V पॉट, करेक्ट? यस और नो? इमीडिएटली इन्फॉर्म बिकॉज आई नीड टू प्रोसीड फर्दर. मैं आगे आगे बढ़ता जाऊंगा यहाँ पे. सो बताइए ये समझा क्या नहीं आपको? दी आउटपुट वोल्टेज, ये बड़ा सा टुकड़ा इज इक्वल टू टू वोल्टेजेस VR प्लस V पॉट. समझ में आया ये? सो V out can be written as VR plus V pot. Understood this statement? Yes or no? Fast. Hello?
Yes.
Ha, very good. Now, tell me what is VR. Sorry, tell me what is V pot. Voltage V pot. Current यहाँ पे आ रहा है ना? तो this current, you know KCL, right? This current is what? I adjust plus IR1. बराबर ना? This current is I adjust plus IR1. Incoming current should be outgoing current, na? So V pot is this current into into R2. So is VR plus R2 times I adjust plus IR1. समझ में आया ये? Because IR1 is over here, I adjust is over here, so this terminal current flowing to R2 will be I adjust plus IR1. Did you understand this? Yes or no?
Yes.
हाँ, चलो अभी next. So V out is equal to VR plus I adjust into R2 plus what is R2 मेरा पॉट है, राइट? R2 इज द वेरिएबल टर्मिनल. IR1 में कैसे लिख सकता हूँ बताओ? IR1 कैन आई राइट IR1 as VR अपॉन R1? इट्स ए रजिस्टर है ना, सो लीनियर है ना. So V is equal to IR, so I will be V by R, correct? So it's actually VR upon R1, correct? समझ में आई ये बात? Okay. But this I adjust for 7805, this I adjust value is very very small. It's 4.2 milliampere. Okay. So I adjust into pot will be very small. Okay, so that's what we replace this. We can include this or we can replace this also, no problem at all. So we can write it there. V out is VR. ये इधर भी VR आया ना, कॉमन हो गया ना. VR plus let me write over here VR into R2 upon R1 बराबर है, plus I adjust into R2 if this comes in the, you know, comes in the way. Okay. Fine. So this is the, we can write it like this. V out is VR into 1 plus R2 upon R1 plus I adjust into R2. So ये रहने देते हैं. Its value is 4.2 milliampere. So this is the formula. अच्छा, tell me what is VR? VR है क्या वैसे? VR is the voltage difference between point 3 and 2 ना, मतलब point output and ground. वो तो मेरा फिक्स वोल्टेज आएगा ना, वो कितना होगा? 5 वोल्ट, राइट? समझ में आई ये बात? हेलो, आर यू अंडरस्टैंडिंग? VR is between pin number 3 and 2, and pin number 3 and 2 for 7805 क्या रहता है? 5 volt, right? So here VR is my regulated output. So VR is 5 volt. Are you getting it? Yes or no? Let me add, open the document again once more. Yeah. So VR is 5 volt only for 7805, because there is a difference between pin number 3 and 2, correct, and that is 5 volt regulated. समझ में आया ये? Did you write out this equation? Completed? Can we start with a numerical? Yes or no? So quickly we'll start. Write down. Design an adjustable voltage regulator using 7805 to vary. मुझे आउटपुट वेरी करना है between 5 and 7.5. So I have to design a adjustable voltage regulator using 7805. So let's start. हमारा proposed circuit कैसे होना चाहिए? Same as last time. So this is my 7805. So here I will connect a resistor, another resistor over here. This terminal will go over here. Okay, this is my output V out. ये मेरा R1 है, R2 है, which is variable terminal? R2. So by varying the value of R2 and R2 over here, we can change this voltage V out. Okay, so here R2 is variable. Rest all the terms are fixed. This is fixed. R1 is fixed. And even VR is fixed. So the only term which can change is R2. So R2 is variable. समझ में आ रहा है? So that's why V out becomes variable. Earlier it was fixed, but now with the addition of these two resistors, it has become variable. Okay. Now let me just mark on this side. Please complete the diagram fast. This is pin number 1, 2, 3, and here we connect the input. So this is my unregulated input. How much its voltage should be? Greater than 7 volts minimum, correct? Then we have two capacitors, Ci and Co, just for the protection purposes. Nothing great involved over here in numerical में उसका काम नहीं है. This is I adjustment, this is VR, this is IR1. Here you get I adjustment plus IR1, and this voltage is V pot. Okay, so how do we start? डिज़ाइन बनाया आपने, ये सर्किट बनाया ना. इसमें हमें आउटपुट में क्या लेके आना है? व्हाट इज द डिजायर्ड गोल? योर रेगुलेटेड आउटपुट शुड वेरी बिटवीन 5 to 7.5 वोल्ट, यही चाहिए ना आपको? सो विल डिटरमाइन व्हेन इट विल बी 5 बेस्ड ऑन द resistor value R2, because R2 is variable. So can we start? Yes or no? So V out will be given by VR into 1 plus R2 upon R1 plus I adjust into R2. This is equation number 1. So for 7805, what is VR voltage given by? Can you tell me? It's 5. And what is I adjust given by? 4.2 milliampere. And let's say R2 is 100 ohms pot, is 100 ohms potentiometer. Okay. So what we are saying is जब भी R2 मेरा मैक्सिमम रहेगा तो वी आउट वोल्टेज विल बी 7.5, या तो मेरा R2 शुड बी मिनिमम और R2 विल बी 100 ohms एंड देन वी आउट शुड बी हाउ मच 7.5, कभी रहेगा when R2 is greater V out will be greater, or R2 is less V out will be less, or V out will be greater. बताओ, directly proportional है ना. So whenever the value of R2 is greater V out will be greater. So this I am assuming, actually I am out of the page now, this is the last page which I have. I'll continue, no problem, I'll continue in the next lecture. This one R2 is equal to कितना है ये pot, 100 ohm pot. मेरा 23 डॉक्यूमेंट है. आई विल कंटिन्यू इट ओवर हियर, नो प्रॉब्लम ना. BEX lecture 23 online 17/4/23. So मेरा adjustable voltage regulator continue. Okay. So क्या लिखा था मैंने? Point number 1 was V out was VR plus R2 upon R1 plus I adjust into R2, right? यही लिखा था ना? So let us rewrite that point. Point number 1 was V out is equal to VR into 1 plus R2 upon R1 plus I adjust into R2. So what are we saying over here? This is equation number 1. हमने क्या बोला इधर? For 7805, how much is VR? 5 volt. And how much is I adjustment?
4.2 pm.
हाँ, तो ये दोनों फिक्स है, ये और ये फिक्स है. अभी हम लोग क्या बोल रहे हैं? We are assuming, we are saying a statement now, statement number 2. Assume for a maximum output of 7.5, हमारा value of R2 is 100 ohm. ये assume कर रहे हैं हम लोग. ओके, तो ये फॉर्मूला में सब्स्टिट्यूट करेंगे ये वैल्यू. फ्रॉम 1 वी आउट की जगह 7.5. सो 7.5 वी आर इज फिक्स्ड 5. दिस इज 1 प्लस 100 अपॉन R1 प्लस 4.2 मिली एम्पियर इंटू 100, बराबर था. सो दैट इज 7.5 इज इक्वल टू 5 प्लस कितना होगा ये 500 अपॉन R1, and how much is this? 0.42. So can I calculate R1 from here? Please do calculate R1 from here. So this is 2.5 minus 0.42 is equal to 500 upon R1. So R1 कितना हो गया बताइए, कितना आ रहा है R1? It's 500 divided by 2.08. How much it is coming? कैलकुलेटर लेके बताइए. Around 240. Is it coming this much? अरे बताइए हाँ कि नहीं. 500 upon 2.08.
2.4. 2.4.
2.4. ये 2.08 है, सो 240 आएगा ना.
Sorry.
सो सेलेक्ट R1 हायर वैल्यू सेलेक्ट करो स्टैंडर्ड, एंड हायर स्टैंडर्ड इज 270 ohms, बराबर है. अभी इसका वोल्टेज रेटिंग कैसे फाइंड करेंगे? वोल्टेज रेटिंग ऑफ द रेजिस्टर. वोल्टेज रेटिंग विल बी IR1 स्क्वायर इंटू R1. सो करंट कितना फ्लो हो रहा था हमारे इसमें? लेट्स से IR1 इज मैक्सिमम करंट फ्लोइंग इन द IC. किधर गया ये? लेट्स से IR1 max is 25 milliamperes. Okay, so कितना हो गया ये? So this is 25 milliampere square into 270, close to 1 watt. Yes or no? So select R1 is equal to 270 ohms comma 1 watt, because resistor is, if you go in the shop and buy the resistor value, they will ask you how much is the wattage rating of the resistor. बराबर है? So select R1 is equal to 270 ohms 1 watt. Now third part, लिखा है इतना everyone? Yes or no? So assume next statement for V out equal to 5 volt, value of R2 is minimum. बराबर ना? अगर मुझे 5 वोल्ट ही चाहिए, वी आर इज 5 वोल्ट राइट, आई डोंट रिक्वायर एनी वैल्यू ओवर योर R2, so R2 can be 0. So value of R2 is minimum, that is 0 volt. Oh sorry, 0 ohm. So वो जो फॉर्मूला था ना अपना, so what will be my output then? So अगर R2 is 0, what will be my formula becomes? फॉर्मूला क्या था अपना? V out is equal to VR into 1 plus R2 upon R1, correct? ऐसे ही था ना? Plus I adjustment into R2. Now if R2 is 0, तो क्या होगा फॉर्मूला मेरा? VR, which is equal to 5 volt. बराबर है? Yes or no? अरे समझ रहे क्या नहीं? हेलो.
Yes, sir.
हाँ. So यहाँ पे पहले मैंने मैक्सिमम वैल्यू पॉट का क्या किया? 100 ohms. R2 100 ohms किया. Now 0 किया. So when R2 was 100 ohms, my output आया 7.5. And now when the R2 is 0, my output आया 5 volt. So I have done my part. So we can write therefore, to vary the output between 5 and 7.5, or 7.5 and 5 volt, to vary the output between 7.5 and 5 volt, we need to vary the R2 pot by from 100 ohm to 0. ओके तो हमारा डिजाइन सर्किट कैसे दिखेगा बताइए? डिजाइन सर्किट बताइए, एडजस्टेबल वोल्टेज रेगुलेटर कैसे दिखेगा? यू विल हैव अ 7805. ओके, दिस इज माय रजिस्टर, वेरिएबल रजिस्टर, दिस माय R1, okay, this is output, this is input. So this is my input, these are just protection resistors CI and CO. No role in the circuit so far for the design. This is V out, which is 7.5 to 5 volt. And what about this register? R2 is a 100 ohm pot. What is the value of R1? R1 मेरा है 270 ohm 1 watt resistor value. Okay, and this is my I adjustment. So ये बन गया मेरा adjustable voltage regulator. So this is adjustable voltage regulator. खाली यही न्यूमेरिकल आते हैं using 7805. Okay, understood this? So how will I make it adjustable? By changing the pot from 0 to 100 ohms. समझ गया? If I keep it R2 as 0 ohm, then my output will be 5 volt. If I keep R2 as 100 ohm, then my output will be 7.5. Huh? Understood this? Yes, no? This is unregulated input. This is regulated output. Fine? Any doubts? So this completes the topic of voltage regulators. This was one numerical which I've covered. Okay? Yes. Now we'll go for the last topic, which is block diagram of DC power supply, which will take around half an hour to complete. No problem. Can we start with the block diagram of power voltage DC power supply? Completed this much? Everyone? Yes, no, what? Can we start with the DC power supply? हाँ ना बोलो.
Yes, sir.
Okay, fine. So write down next topic, block diagram of you want to write the answer as it is, right? Block diagram of what was the topic which they call you, which they call in the syllabus, DC regulated power supply. DC regulated पावर सप्लाई. सो पहले एक्सप्लेन करूँ या पहले लिखाऊँ, बताइए. शुड आई मेक यू राइट फर्स्ट और शुड आई एक्सप्लेन फर्स्ट? बिकॉज आई कैन डू बोथ.
Right, sir.
अच्छा ठीक है. सो लेट्स स्टार्ट ड्राइंग फर्स्ट ऑफ ऑल. Okay, so let's start with the drawing. So first of all, you have your transformer, AC input given to the transformer. So draw the transformer first. ये है symbol of the transformer. This is a step down transformer. Okay, this is given to diode rectifier block. So this is a transformer. We give it to diode rectifier block. Then we give it to the filter block. Then we give it to the voltage regulator. Okay, and then we give it to the output load. If we want to connect any. Now load can be a mobile phone or a anything else. So please draw them, draw the circuit diagram. This is AC mains. AC mains का specification is 230 volt, 50 hertz supply. Okay, this is AC input. Okay, this is input, AC input, 50 hertz input supply, which you all get in your households. This is step down ट्रांसफार्मर, ये जो ब्लॉक है ना, ये वाला ब्लॉक है। तुमने ट्रांसफार्मर कभी देखा है पहले? हेलो, इन योर स्टडीज फाइल रेक्टिफायर्स में ट्रांसफार्मर देखा है क्या नहीं? बताइए। हेलो।
Yes, sir.
हाँ, तो वो वही है, दिस इज द ट्रांसफार्मर। ओके, हियर डायोड रेक्टिफायर में विच रेक्टिफायर यू विल नॉर्मली प्रेफर? There are various types of rectifier. We normally prefer bridge rectifier. Filter may depends upon the type of the load. So it can be C filter, L filter or pi filter. तुमने filter भी पढ़े है ना? Voltage regulator will be regulator ICs which you have studied. So 78XX, 79XX. And load can be a mobile phone charger or a laptop charger. समझ में आया? This is 230 volt RMS value, remember that. To AC main, step down transformer, diode rectifier, filter stage, voltage regulator and the load. So load may we get a constant DC, so this is V out and you should show current also IL. So here is my AC signal hypothetically. ये मेरा बहुत ही बड़ा AC signal है. This is AC and at the output I'll get a DC voltage. So this is V out versus time. तो इधर आउटपुट क्या आएगा आपका? At the output of this rectifier at this stage, output will be a step down version of the input. This is input, this is output of the transformer versus time. So this is again a AC quantity. Okay, then output of the rectifier will be ऐसे रहेगा, देखो. Okay, this is pulsating DC. Okay, output of the filter will be like this. Let me draw it precisely. I hope you are drawing along with me. Output of the filter will be, let me show it to you how it will be. Matlab, if I want to show it, it will be like this. जो black color वाला, ये वाला. This is filtered output. Okay, this is called as filtered DC output. And at the finally over here, what do you get? A constant DC output. Okay, versus time here, so all of them are versus time. So this is V out. So this is DC output. Drawn? सो बीच में मेरे बहुत सारे स्टेजेस है. सो हमारे कितने वेवफॉर्म है यहाँ पे? लेट मी मार्क इट. इनपुट, देन आउटपुट ऑफ ट्रांसफॉर्मर, देन पल्सेटिंग डीसी, दिस वन. ओके, देन फिल्टर्ड डीसी आउटपुट एंड फाइनली डीसी आउटपुट. जो 5 वेवफॉर्म बनाने हैं विद रिस्पेक्ट टू टाइम, हम लोग ये बनाएंगे. पर फर्स्ट ऑफ ऑल राइट इट डाउन. So this is the block diagram of DC voltage regulated power supply. Can we start writing? Are you done? हेलो, कंप्लीट किया है आपने? हेलो, Can I start writing? You are ready? Okay, let's start. So लिखो यहाँ पे first point you can write and DC regulated power supply consists of the following blocks. Okay, लिखो यहाँ पे first block is transformer, second is rectifier, third is filter, fourth is regulator. Are you writing along with me? Hello? Just yes or no bolo so that I can slow down. A DC regulated power supply consists of the following blocks: transformer, rectifier, filter, regulator. Can I proceed? Okay. Yeah, can I start? Okay, fine. So write down the power supply is fed from 230 volt RMS 50 Hertz AC mains. The power supply is fed from 230 volts 50 Hertz AC mains and it delivers a DC voltage usually in the range of 5 volt to 20 volt. Okay, तो मतलब what is the input of the power supply? Input of the power supply is AC mains and it delivers a DC voltage at the output. Okay, and it delivers a DC voltage to an load which is an electronic circuit, for example मोबाइल फ़ोन चार्जर. आपका जो मोबाइल फ़ोन चार्जर है दैट इज़ अ लोड. तो मेरा सोर्स क्या है? द पावर सप्लाई इज फेड विथ 230 volt RMS 50 watts AC mains and delivers the output voltage in the range of 5 volt to 20 volt. Delivers a DC voltage to an load which is an electronic circuit, for example a mobile phone charger. Okay, understood this?
Yes, sir.
Okay, great. Now can I go to the next point? Okay, next is point number 3. Okay. Uh, Write down the DC regulated output voltage V out is required to be as constant as possible. Okay, in spite of variations in AC line voltage and in the current drawn by the load. Okay, so the DC voltage, DC regulated output V out is required to be as constant as possible in spite of variations in the AC line voltage and in the current drawn by the load. लिखा है ये? Completed this much, students? Okay, the DC regulated output V out is required to be as constant as possible in spite of variations in the AC line. Okay, now next point, can we start? Yeah, are you all ready? Okay, next point is uh, I think I have to stop the recording because at my place electricity has gone.